formula for the area of a sector on a circle. So we've got that same circle, angle at the center of it. We'll call the angle theta. We'll call the radius r. This time we're interested in the sector that is formed by this angle. The sector is like this piece of pie that was created when this angle rotated. Specifically, what we want to know is how much space is in this sector. In other words, what's its area? You might remember that area is measured in square units. For example, I've got this little square over here, 1 centimeter by 1 centimeter. This is called a square centimeter. So when we talk about area, we'd be talking about, well, how many of these little squares fit inside this shape? Well, coming up with the formula again is pretty straightforward because of the fact that the area would be proportional to that central angle. If I were to double the angle, then of course what would happen is I would end up doubling the area of that particular sector. If theta and the area are proportional, then I can form a ratio of the area of the sector. I think I'll use a little s to remind myself what that is, the area of the sector to the angle. That ratio has to be constant for all area angle pairs. So if I can just find one, I'll be able to create an equation. Well, let's use the one we know the most about, which of course would be the angle that goes all the way around the circle, in which case the sector of the circle would be the entire circle. So I would have here the area of the entire circle, and the angle, of course, would be 360 degrees. So there's a relationship between the area of the sector and the area of the circle. Watch what happens, though, when we go to radian measure. The area of the sector divided by the angle. Well, let's see. The area of a circle, we have a formula for that from geometry. It is pi times the radius squared. 360 degrees in radians is equal to 2 pi. Well, the pi's cancel here, and instead of writing r squared over 2, I'm going to write this 1/2 r squared, right? That's the same thing, dividing something by 2, multiplying it by 1/2, same thing. And then let me multiply both sides by theta. And when I do that, I come up with the formula we were looking for, which is the area of the sector is equal to 1/2 r squared theta, where a stands for the area of the sector, r is the radius, and theta is the angle. Again, it's a great formula and very easy to use, but we obtained it by switching to radian measure, so it only works if the angle is measured in radians. Aren't radians great? Thanks for watching.